In the last presentation, we completed the sum of product, and it is of two types. The first one is the canonical or standard SOP form, and the second one is the minimal SOP form. Let us revise it quickly, then we will solve two problems that I have already written here. In canonical or standard SOP form, each minterm is having all the variables in normal or complemented form. So if I see this example, in this the function is f and there are three minterms. The first is a complement b, the second is ab, the third is a complement b complement, and in total we have two variables. We have two variables, a and a b, and you can see that this one is minterm 1, this is minterm 3, and this one is minterm 0. So each of this minterm is having a and b whether in normal or complemented form. By normal I mean we have a or b, and by complemented form I mean a complement or b complement. So in M1 I have a in complemented form and b in normal form. In M3 I have a and b in normal forms, and in M0 both a and b are in complemented form. So definitely it satisfied our requirement that each minterm must have all the variables in normal or complemented form, and here in all the minterms we have a, b in normal or complemented form. So this is all about the canonical or standard SOP form. In minimal SOP form, each minterm does not have all the variables in normal or complemented form. We use Boolean algebra or K-map method or tabular method to minimize this, and we have the minimal SOP form, and in that we don't have all the variables involved in normal or complemented form. Like in this case you can see we don't have b and c. A, b, c are the three variables for this function g, and in the first minterm we don't have a b or c, and in the same way in second minterm we don't have a. So this we call as the minimal SOP form. I hope you understand these things. Now we will move to the example number 1. In this we have the truth table that you can see, and for the given truth table minimize the SOP expression. So let's see how we can have the SOP expression by using this truth table. So let's move to our solution. If you remember, I told you we use SOP form, or we write SOP form for the output when it is high. So if I say 1 is there, then I will write the variable as a, and if 0 is there I will write the variable as a complement. If a is my variable and it is 1, I will write it as a, and if it is 0 I will write it as a complement, and we have to write down the SOP form for the high output only. So these are the two cases for which the output is high, it is 1. So let's write it down quickly. For the first case you can see a is 0, so I will write a complement, and we have b as 1, so I will write b. Or for the last case I have a as 1, b as 1, so simply a and a b. Now we have to minimize the SOP expression, so I have to minimize it by using the Boolean algebra, and I will take b as common, so I'm left with a complement or a and b, and you very well know that a complement or a is equal to 1 and b. This will give me y as a b, and you can clearly see that when b is 0 the output is 0, when b is 1 output is 1, again when b is 0 output is 0, and finally when b is 1 output is 1. So simply y is equal to b, and this is what we have as our result by using the Boolean algebra. In this way you have to approach for the SOP expression. And the question number 2 says simplify the expression for m equal to 0, 2 and 3. The minterms are 0, 2 and 3. Instead of having the truth table we have the expression like this in which the minterms are involved, and you can see there are two variables. So let's try to write down the SOP form. This one is the canonical or standard SOP form, and this one y equals to b is the minimal SOP form. And you can see that this canonical or standard SOP form we have directly written from the truth table. We have directly written from the truth table, and in this all the minterms have each variables in complemented or normal form, whereas in this we don't have all the variables in normal or complemented form. A is missing here. In the same way we have to approach for the question number 2, and I will write down the canonical form first. We have M0 or M2 or M3. M0 is A complement B complement. If you remember from the truth table, let me do it here. This is 0 0, so I have M0. The 0 represents the decimal equivalent of this 0 0. 0 1 is M1, 1 0 is M2, 1 1 is M3. These are the min terms, and M0 is there. It means the function y is high for the first case. So I have written A complement B complement because A is 0, B is 0. In the same way for M2 you can see A is 1 whereas B is 0. So I will write down A or B complement, and for M3 you can see A is 1 as well, B is 1. So I have A and B. So this is my canonical SOP form, and I will use Boolean algebra to minimize it. So let's do it quickly. You already know how to do that. And I can see B complement can be taken as common, or you can take A as common from the last two terms. You can do whatever you want. So I'm left with A complement or A, B complement or A and B. A complement or A is 1, so 1 and B complement or A and B. 1 or B complement is B complement or A and B. Now from the distributive law, if you remember, I'm using it so many times, and when we were studying the Boolean algebra I told you that I'm going to use it a number of times. A complement or A and B, if this is the case, then I can write it as A complement or B. I have to just neglect this A. In the same way I have B complement or A B, so I will neglect this B and I have B complement or A. So this one is the minimal SOP form, the sum of product form, and this one is the canonical sum of product form. So this is how you have to solve the problems. I hope you got these things. If you have any doubt you can ask. In the next presentation we will study the pause form. So see you in the next one.